Apatosaurus, Diplodocus, Argentinosaurus, these are some of the most well-known sauropod dinosaurs out there, but what if you didn't like your sauropod with an extra long neck? Say you preferred it more like this, short, stubby, kind of like the neck of a T, Rex, but attached to a much longer body. Well, if that's the case, then boy do I have the dinosaur for you. This is Brachytrachelopan. And no, that isn't some fan edit of a different dinosaur. That really is how this dinosaur looked. With a neck so short, its head practically sat on its shoulders, this bizarre sauropod really did look like the love child between a sauropod and a theropod. So what was this weird-looking thing, and why did it evolve such a short neck? Hi, and welcome to Paleologic. Today we are talking about one of my favorite goofy-looking dinosaurs, Brachytrachelopan. Like many of our favorite dinosaurs here at Paleologic, this dino is from South America. Specifically, it comes from Argentina, where it was found in the Candelaria Formation, which dates back to the late Cretaceous period around 86 million years ago. It lived alongside other familiar dinosaurs like the recently updated title card of this video, a terrifying mix of a Giganotosaurus and a Maposaurus. And it got its own spotlight in 2007 when it was named the provincial fossil of the Candelaria Formation. The name Brachytrachelopan comes from the Greek words brachys, meaning short, trachelos, meaning neck, and pan, meaning large. So essentially, this dino is known as the short-necked giant. Now, let's get into the anatomy of this strange beast. The first thing you're going to notice with this dino is definitely its neck, or maybe it's the complete opposite, the lack thereof. This guy had a seriously shortened neck, just 24 vertebrae long instead of the typical 10 to 12 sauropod neck. Its neck was also really thick towards the base, unlike other sauropods which have long and slender necks. Now you might be wondering how this dino could even move with such a short, stubby neck. I mean, they were pretty much stuck bending their necks forward and backward. And while this is true, keep in mind that this neck was still able to turn side to side, although maybe not all that far, and given that it was still basically a sauropod, it still had the super flexible whip tail that can probably make up for some of its neck's shortcomings. Also, if you're getting a little neck pain from all that craning, just remember, Brachy had a serious case of text neck. He didn't even live in a time where people looked down at phones all day. That poor guy was literally born with it. Okay, now let's take a look at the rest of its body. In terms of overall size, it was quite small compared to other sauropods. It was about 9 meters long and maybe 3 meters tall at the hips, putting it at around 5 tons. Its skull was also fairly small, about a third of the length of its relatively short tail, and it had a narrow snout with lots of sharp teeth for shearing through plants. Now there is some debate over whether or not it was a sauropod, given that it doesn't really fit the typical sauropod mold. For one thing, it had a very small brain compared to the rest of its body, which was closer to the size of a theropod brain than other sauropods. Now, this could be because it was actually more closely related to theropods than other sauropods, or it could be because it simply evolved a smaller brain after diverging from other sauropods. More evidence needs to be gathered before we can say for sure, and because of this, scientists aren't exactly sure what its closest relatives are. Some analyses place it as a basal sauropod, meaning it's more primitive and closer to the common ancestor of all sauropods. However, other analyses place it as a member of the family of long-necked sauropods. So more work needs to be done to sort out its exact evolutionary relationships. But regardless of what group it belongs to, it would have still been one of the top predators in the area. So now you're probably wondering, why does a herbivorous dinosaur need a big brain? Or why it even has one at all if it was already at the top of the food chain. Well, larger brains may help animals find new food sources and solve problems in novel ways. Having a larger brain also means the animal can use its brain power to stay active during the day. See, the brains of nocturnal animals tend to be bigger because they need to be more cognitively active at night, whereas the brains of diurnal animals, those active during the day, tend to be smaller. If Brachy was indeed a sauropod, it likely ate lots of low-growing vegetation, which wouldn't require much cognitive function. But this doesn't explain the small brain hypothesis. Maybe we're just looking at it the wrong way. Perhaps it wasn't Brachy's brain that was too small, but rather the brains of other sauropods were abnormally large. They were just bigger-brained than they needed to be. But then, why would they have evolved such large brains in the first place? Well, again, there's a lot of speculation. But one idea is that having a larger brain helps protect against parasites. Yes, even dinosaurs had parasites. Scientists think that a larger brain requires more energy, and with more energy comes higher body temperature. And animals with higher body temperatures are less hospitable to parasites. So perhaps sauropod dinosaurs evolved larger brains to stay nice and toasty. Or maybe they were just big-brained because they were already warm thanks to being gigantic. In the end, the reason behind Brachytrachelopan's short neck is just as mysterious as the reason for its tiny brain. The best guess is that it's an example of what's called a derived character. What does that mean? Well, characters are just the different traits that we see in animals. You know, feathers, fur, number of legs, things like that. Derived characters are traits that evolved in the lineage leading up to an organism. Take feathers, for instance. Feathers are a derived character of birds. Birds today come in all shapes, sizes, and feather styles, but feathers themselves are a relatively new development in evolution, evolving in the lineage leading up to birds sometime around 150 million years ago. Even though feathers evolved only once, all living birds inherited the ability to grow them through their shared ancestry with other birds. Now take a look at this goofy-looking dino. All sauropods have really long necks except for Brachytrachelopan, so we can assume that this trait must have evolved somewhere in its ancestry. Somewhere along the line, this population of sauropods chose short, stubby necks. Why they did this remains a mystery, but this doesn't mean we haven't tried to solve it. One idea is that its neck evolved because it was a juvenile sauropod that just hadn't fully grown into its long neck yet. However, other species of sauropods also have short necks when they are young, and their necks just get longer with age. So that doesn't seem to be the case. Another theory is that it lost most of its neck vertebrae secondarily, meaning it started out with a normal sauropod neck, but then evolved to have fewer neck bones. There's actually an example of this in modern times. The giraffe has 7 neck vertebrae, just like every other mammal, but its ancestors also had 7 neck vertebrae, same as today's deer. But as they diverged, giraffes started growing more and more neck vertebrae until they ended up with the long, stretchy necks that we know today. Could something similar have happened to Brachy? Maybe. But given that it was about the same size as adult sauropods with shorter necks, this doesn't seem likely. Also, if it evolved from a long-necked ancestor, you would expect to see fossils of intermediate forms, but we don't. Plus, the joints in its neck vertebrae are different from other sauropods, suggesting that they evolved independently, not as a result of losing vertebrae. Finally, there is the possibility that the short neck was a result of sexual selection. After all, short necks have proven to be pretty popular in the bird world. Male birds often sport colorful, elaborate plumage to attract mates, but their neck often takes center stage. Take the greater sage grouse, for instance. Male sage grouse have thick, short, inflatable necks that they puff out to attract females, while females have thin, flexible necks for seeking out food. Similarly, male brachy may have had showy, brightly colored skin around their neck that they used to attract partners, while females had more typical, longer sauropod necks. But ultimately, without finding more fossils and more data, we may never know why Brachy decided to go for broke with the short neck. So, what's next for Brachytrachelopan research? Well, obviously more fossils need to be found. We only have 2 specimens to study, which makes it difficult to draw conclusions about this weird dino. Also, more data on related sauropods will help scientists better understand where this dino fits in, especially with the recent reclassification of other sauropods, And finally, more research on how the neck works will help us learn how it moved and whether or not it actually had any advantages to its short neck. Ultimately, understanding what advantages or disadvantages it had will help us understand why it evolved the way it did. So, what do you think? Did you already know about Brachytrachelopan, or have you stumbled upon it, like I have, in Jurassic Park, Operation Genesis? Let me know down below. Also, if you liked this episode, be sure to check out this one on another quirky dinosaur, Ankylosaurus. Thanks for coming along on this journey through time. I'll see you later.